Science is a set of disciplines, really, by which we think we're getting some kind of a grasp on a reality that is out there. And the kinds of methods we use are experimenting, setting up hypotheses to account for what we observe, and then testing them by repeated observation. So, for instance, if we want to know how the solar system works, we look and examine the motions of the planets and make lots and lots of observations, and then comes the hard task of trying to account for them. And in the past, people thought that perfect motion was circular, and so they tried to fit the motion of the planets into a circular orbit. But Kepler, the very brilliant scientist, he couldn't quite fit it into a circular orbit, and he had the brilliant idea of breaking out of that mold and thinking in terms of ellipses. And he decided to try to fit an ellipse to the motion of the planets and found it worked. And that was a huge step forward in the history of science. One aspect of how we get to know is by going and looking, testing, repeatedly testing. And of course, the ideal situation is that we set up a theory of understanding where if you do the experiment that I suggest, you come up with the same answer that I've come up with. That's the ideal. But we don't always get there, because there are lots of things we can't repeat. For instance, the whole history of the universe has only happened once, so far as we know. So you can't repeat that. So we have to use another method of thinking, and that is inference to the best explanation. In other words, we ask ourselves, we have a situation, what would be the best explanation that would account for that? We can't, of course, prove it 100%, but we can at least give pointers and evidence that it's true. And perhaps I, as a mathematician, should add to that, that you can never prove anything in the mathematical sense in the natural sciences. Proof only occurs in my own area of pure mathematics, where you're dealing with accepted rules of logic and you're asking yourself the question, what can I infer from a set of axioms? In all the other natural sciences, you can only speak of evidence. If we stand back from it and think of the fact that there are basically two competing worldviews into which explanation has got to be fitted, that come up to us from the ancient world. One worldview says this material universe is all that exists, and therefore all explanation has got to be bottom up. It comes from mass energy upwards, so that mind has got to be explained solely in terms of brain, and brain has to be explained solely in terms of physics and chemistry, and so on, down to the atoms of which the universe is built. That's one worldview. We call it materialism. The other worldview, which is equally ancient, is that this universe is not all that exists, but there is a God who created it, and therefore there's a transcendent dimension. Explanation, therefore, can be wider. It can include the bottom up, and it can include the top down. Now, when I look at those two worldviews, which are strongly represented in this University of Oxford, I stand on the theistic side and many of my colleagues on the atheistic side. I say, look, all of us are doing science. In order to do science, we must place reliance in the human mind. Now, here's the odd thing, and it's a very provocative thing. If the human mind is nothing but the brain, and if the brain is the end product of a mindless, unguided process, why should I trust it? Why should I believe anything it says, including the fact that it's the end product of a mindless, unguided process? And one of my most serious objections to the atheistic interpretation of the universe is that it undermines the very rationality that's needed to do science. This has got nothing to do with belief in God. It's just the fact that you're undermining